Hello, I am Ajay Reddy. My case study is that human factor in autonomous driving, like what human roles does impact in the autonomous driving, like roles, risks, and responsibilities. And my objective is that how can autonomous vehicles can mimic our human intelligence or uh, integrated our human intelligence and replaced in autonomous vehicles by reviewing research papers. And my case study focus on understanding the evolution of human employment in path planning or decision making control, impacts on such various aspects like weather conditions and overtaking conditions and everything. And the basic difference of human role and human factor is that role is what job does the human have, and factor is what makes the job to do the job.
Yes, yes, yes.
And my first paper says that human inspired autonomous driving. And the overview is that it it takes the behavior models to improve the autonomous driving system by the human and mimicking the human intelligence by enhancing the safety, interoperability, and social accessibility of autonomous vehicles, like how we decide the path planning and how we decide the decision making and all. And the objective is that uh, it takes the algorithm of hybrid RRT that improves the path planning efficiency and also in colored environments to enhance the exploration convergence balance of traditional RRT using an alpha parameter. Alpha parameter is that adjusting we can say as this, steering, how we can control that for uniform and non-uniform sampling, and to reduce the node visitation and improve planning speed while maintaining high quality and optimal path trajectories. The basic difference of RRT and hybrid RRT is that RRT cannot decide the path when it has the multiple multiple things, but hybrid RRT can decide one in if we give infinite paths. And the methodology is that it has a smart sampling and fixing the path and testing in maps. The smart sampling is that it mixes the random maps to find the best path and fix the path, like it keeps checking and improving the path by one, and it makes a short and better thing. And the limitations of the paper is this survey paper does not any training process like in a real time world, and it mainly focus on just an academic research but not in the real time process, so it may not fully reflect on industry practices or commercial systems. That's what I want to say from paper one. And this is the last slide for paper one. It The results of paper one is the better path quality and faster planning and fewer nodes used, and it also tested in 2D maps like a simulation process. Uh, and my paper two says that how human intelligence can mimic for the autonomous driving, like it insights are from the human cognition and behavior can inform the development of autonomous driving, and also it research based levels of perception of behavior and functional and architectural and cellular, and it decides the how sudden decision making can be done by the autonomous driving, like how we done. And it emphasizes the potential benefits of the integrating of human inspired approaches to the enhanced decision making to interaction with the autonomous driving. And the objective is that categorize human inspired approaches in autonomous driving based on different operation levels and evaluate the advantages of integrating of cognitive science, neuroscience, and physiology into autonomous vehicle development, like our brain to the autonomous cars, identify gaps and future directions for research in human inspired autonomous driving systems. And methodology is that it reviewed 200 plus across papers around across the integrating of AI and neuroscience and psychology to understand how human thinking can guide autonomous vehicle design. And it created a four-level framework like cellular, artificial, and functional and behavior to characterize how human traits are used in autonomous systems. And advantages and limitations. Advantage is that better decision making, improved interaction, enhanced learning capabilities, and interdisciplinary insight. but the limitations are practically maybe it is not possible or possible in the future, and it is only for real limited real world testing, and it is so complex in for implementation, and interdisciplinary gaps like collaboration between AI fields and human science. So this is what I conclude from the paper two. And my paper three concludes that driver assistance after handover of control from automation. Like we can drive and also the AI can drive. Like by our human driving, AI can learn how to interact with the situations and sudden decision making, like how we do. And the overview summary is that how driver interacts with semi-autonomous vehicles during the transition of control from the autonomous system back to the human driver. It focuses on understanding the challenges and behaviors with such handovers to the improved driver assistance. The objective is that to analyze driver behavior during handover conditions and design to better driving assistance system during handovers, and the factors that influence success of control transitions. And methodology. Simulated driving scenarios. Participant, Participants engaged in the driving simulations where control was transferred from the AI to the human. Performance monitoring. So researchers measured driver response times, control accuracy, and situational awareness. And data analysis. The data collected was analyzed to determine patterns and factors after successful. And this is the paper for. Title is that driver trust in autonomous driving system. Like in the case of overtaking and passing. Like this investigates how driver trust in autonomous driving systems is affected during overtaking or passing. Like uh, the driver should trust on the human AI. Like does it really takes overtake or pass by the vehicle or not? It examines. That's what it says. It examines the relationship between system behavior and driver trust, providing insights into designing areas that maintain or enhance driver trust during complex driving situations. And this is the objective to enhance how voting and man passing manuals by ADS influence driver trust. And this is the methodology: driver simulator experiments and trust measurement and data analysis. And this method is the trust and measurement collected subjective trust ratings from participants from each scenario, and also it analyzed the relationship between system behavior parameters and reported trust levels. And these are the limitations. Simulations contention based on findings are based on the simulator, which may not fully replicate on real world, and scope of scenarios. Focus solely on overtaking and passing, not emphasizing on other driving situations. And my paper 5 says that generalizable autonomous driving system across diverse adverse weather conditions. Like it trains however the weather is, it trains the data and move on the road. This paper talks about how self-driving cars would make better in weather like fog, snow, and rain. It takes the bad weather conditions from the video frames, and it trains by complexity whatever it is, and gives the clear weather to move on the road. We can say that simply as learn from the bad weather directly. And the main goals are make self-driving cars perform well, either whether in bad weather, removes the need of training system with only clear weather images. No need of clear images. It can also drive in the fog conditions or snow and rain conditions. Improve how well the car understands on road surroundings in tough situations. As I said, it watches the video frames and mixes frame randomly. This prevents of the system from getting too used to one pattern. Like it doesn't get addicted to only one. It mixes the multiple frames and move on, and keeps the model simple. It adds rules to avoid making the model too complex. And these are the limitations. Need powerful computers to run. Harder to add into current car systems. Need more testing in real world system. Paper 1, paper 2, and paper 5. Minimum Paper one focus on path planning and paper two focus on path planning with human traits, and paper three is trust in autonomous vehicles, and fourth is when the car is overtaking or passing. The paper five is training in the bad weather conditions, and human role is like in path one just model brain like path choices, and paper two is like AI should adapt, and paper three is over trust, and paper four it innovation and limitations for the paper one. Common limitations for the everything is it cannot fully replicate on the real world systems. And the method for paper one is brain-inspired model-based simulation, and paper two is compare existing algorithms, and paper three is survey research based paper, and fourth is driving simulator plus trust ratings, and fifth is frame learning plus regularization. And I choose and why which paper I chosen and why I chosen the base paper as fifth paper, like a weather robust condition driving license for driving model for autonomous vehicles. Uh, Real world relevance. Autonomous vehicles must operate safely in all conditions like rain, force, knock. This paper tackles the important challenge of bad weather, which is often ignored. The most accidents are happen because just because of weather in the morning or in the day and night conditions. So I choose an base paper five is the best for that, and improve the safety and reliability. The models helps AVs to see understand the better road condition, visibility is low, and making decisions safer and more dependable. Bridges and technical gaps. While other papers focus on just path planning and technical things, these papers focus on environment conditions and also prescription, making strong addition to oral study. And this is the problem statement. While AVs are autonomous vehicles are advanced rapidly in sensing, planning, and control, their adaptive ability to interact safely and naturally with human remains limited. Many systems struggle that replicate to human decision making or build the trust or adapt to complex situations, and also understanding and integrating human behavior, perception, and exceptions is crucial for reliable and acceptable AV development. And the study explores how human factors can be better incorporated into human driving systems through different types of research papers. And these are the challenges across all those papers: high compression load, and limited temporal system, and sensor dependency, and generalization issues. High compression load is that it really requires high processing power, which can slow down performance on real-time systems. Like it may not work when it really necessary, and also it is just a limited for the real-world testing. And sensor dependency, the system relies mainly on camera input, which can be unreliable during extreme fog or rain or snow. And the general issues is that the model may struggle to work across different geographic locations, unexpected or unexpected weathers, which cannot be trained on. And this is the proposed solution of the paper, like use later models for real-time use, like optimize the AI algorithms for fewer users, like memory and power, so it can run smoothly on real autonomous vehicle hardware. Like it doesn't computation high process models. So if we use less AI models, that we can it can run smoothly. And the test in real world conditions, like beyond the simulation, run the model in actual cost during real weather, like rain, fog, snow, and whatever it is, and prove its reliability, at least by testing on the old cars or like that, and combine with other sensors, like how that videos take from video frames. Like we have to integrate with the multiple sensors like lidar and radar along with cameras, especially in low visibility environment, so that it can show the efficiency of the particular systems, and adapt to training environments. Extend to the system to handle moving objects like vehicle positions during bad weather, but not on. It says that when the leader or radar the taking the bad weather conditions, it just not focus on the road, and also it focus on the prediction while walking or crossing the road or crossing the road. So, so by this, I want to conclude the paper, and this is the conclusion. This study mainly highlights the importance of human factor in autonomous driving systems. Like we have seen the five papers, and one is the path planning, and another is the driver assist, and another is the weather conditions, like that. So it becomes clear that integrating human behavior, trust, cognitive science, and decision making into autonomous vehicle systems improves safety, performance, and user acceptance. While the current methods show great promise, they also face challenges like same as this, like limited testing and lack of real-time adaptability and driver trust issues. More research and human-centered design are needed to make autonomous vehicle truly intelligent, safe, and reliable in diverse real-world conditions. So, in future, maybe all these can be implemented. So, by this, I want to conclude the my case study. Thank you.